In this lecture, we will talk about network components. We will start with the IP address, subnet mask, gateway, static IP versus DHCP IP, Ethernet and virtual interface, MAC address. Let's start with the IP address. An Internet Protocol address is a numerical label assigned to each device connected to a computer network that uses the Internet Protocol for communication. IP address looks something like this. Most networks today, including all computers on the Internet, use the TCP/IP protocol as the standard for how to communicate on the network. In the TCP/IP protocol, the unique identifier for a computer is called its IP address. There are two standards for IP addresses: IP version 4, IPv4, and IP version 6, IPv6. All computers and networked devices with IP addresses have an IPv4 address, and many are starting to use the new IPv6 address system as well. IPv4. IPv4 uses 32 binary bits to create a single unique address on the network. An IPv4 address is expressed by 4 numbers separated by dots. And here's an example. Each number represents 8-digit binary number, also called an octet. These 8-bit sections are known as octets. The example IP address then becomes, and you can look at this example, if you see zeros and ones, these are the 8-bit sections known as the octets. And your computer only understands zeros and ones. But when you see an IP address, you can understand it better, and that's how it looks like. Let's talk about the IPv6. When the internet exploded, IPv6 was created as it was realized that we may run out of IPv4 addresses. IPv6 uses 128 binary bits to create a single unique address on the network. An IPv6 address is expressed by 8 groups of hexadecimal numbers separated by colons. If you can see the example, this is how they look like. Groups of numbers that contain all zeros are often omitted to save space, so they will look actually like this. Let's talk about subnet mask and subnetting. The practice of dividing a network into 2 or more networks is called subnetting. For IPv4, a network may also be characterized by its subnet mask or net mask. For example, 255.255.255.0 is the subnet mask for the prefix 198.51.100.0/24. Below is an example of subnet masks used by different classes. If you look at the class A, its first octet range starts from 1 and going up to 127. Class B goes from 128 to 191, and Class C goes from 192 to 223. And you can also see the default subnet masks for those classes as well. Gateway. A gateway is a network node that connects two networks using different protocols together. While a bridge is used to join two similar types of networks, a gateway is used to join two different networks. Common gateway is your home modem or your router. In most cases, it will look something like this or similar: 192.168.1.1. Static IP versus DHCP or dynamic IP. A static IP address is a dedicated IP address that does not change. This is an IP address that is used by your system every time you log into the network. DHCP or dynamic IP address is an IP address that will automatically be chosen for you from a pool of IP addresses that are assigned in the DHCP scope available on your network. Think static as permanent and DHCP as a temporary IP address. Let's talk about Ethernet and virtual interface. Ethernet interface. This is usually the NIC, network interface card, that is on the back of your computer, also known as a NIC. Virtual interface Very common now in virtual environments such as Oracle VM VirtualBox or VMware, etc. Virtual interfaces exist only in software. There are no physical elements. You identify an individual virtual interface using a numerical ID after the virtual interface name, such as ETH0. MAC address. Every NIC, virtual or physical, has a hardware address that's known as a MAC. MAC stands for Media Access Control, and each identifier is intended to be unique to a particular device. A MAC address consists of 6 sets of 2 characters, each separated by a colon. And you can look at this example. This is how they look like. This covers network components. I hope you learned something useful in this lecture as well, and I will see you in the next one.